So let's think about what's going on. We have some football game. At the beginning of the game, you can either bet or not bet. Okay? Then at halftime, based on the score, you can either cancel your bet or what? Continue the bet?
Yes. If you cancel, you only get 5 back.
Yeah.
Yeah, you get 5 back. Okay.
So you lose 5.
All right. So we need to sort of draw a decision tree.
Okay.
So no matter what,
he's going, he's going to bet.
he is
So-
making a bet.
Yeah.
Okay.
So, what's his name? Sean?
Sean Zulansky.
Sean is always going to make a bet.
He's a really good.
But, alright, so he has to make a decision if he's going to pull out at halftime or not. That's
Okay.
the main thing, right?
Right.
Alright, so he has to make a decision.
Well, hold on. But something happens before he makes that decision.
Either the team is losing or winning at halftime.
Yeah.
yeah, so
Yeah.
isn't the decision chosen at halftime, though?
Yeah, but first there's a random event.
Yeah, it's kind of like the underwear. It comes first.
Yeah.
Yeah.
So I say it breaks. I think it breaks up into 2 branches. It's either the team is leading at halftime
Absolutely.
or losing at halftime.
We're just
Yep.
working
And
working
then
through
it's
last
decision.
year's exam problem. Yeah. We just started number 4. It's okay.
Alright, so then the decision.
We're drawing the decision tree for it.
Okay, so 8.8% of the time it's leading at halftime, and then so that makes 0.2 is losing.
What was the 0.8? Yeah?
Yeah, 0.8 is leading at halftime, so that means
0.2.
Yeah, 0.2 is losing. Okay, so then from there.
If 80% winning, the probability to win is 40%.
Oh, yeah.
Yes.
So then each one of
Okay,
these
so
breaks
this
off
Alright.
into losing,
You're
okay,
losing or winning.
right? Yeah.
Alright, so losing or win. So we have, let's say,
You have to make a
loses
circle.
or wins. So 80% of the time he has
0.4
a
win,
chance.
0.4 win.
If the team is leading at halftime,
They
then
go
we
on
win
to win
0.4 of the
40%
time.
of the
0.4
time.
win.
And 0.4,
And
0.6.
losing.
Now they're losing at the half.
0.4 win.
0.5.
0.5
It's
win.
0.5.
Both of them
Yeah.
0.5.
Okay, so I am confused as to where we should put whether he wins
Okay,
or not.
so
Yeah.
what's the decision on the left?
That's decision if
Is-
he
if-
continues the game.
Okay, so
Or,
let's put continue as the down, yeah?
Continue.
Oh,
Or if
okay.
he backs out and his automatic reward is -$5. Right?
Yeah.
I
So that's
see.
that. It all depends on how you want to sort of set it up, but -5 is fine. Or you can view it as, so you're doing it relative to, like you're doing what, 10 minus 5?
Yeah.
Right? Or minus 10 plus 5. That's what you're doing.
Yeah.
Right? You put in $10, but he got $5 back.
So,
So his net gain is
Negative 5.
so
Negative
should I
5.
write?
So you could do that. That's fine.
Mhm.
Or you could just write $5,
Mhm.
right? And we'll do it from a baseline of $0. What
Mhm.
does he get back?
Okay.
Okay.
Zero
So
minus- 0 minus 5.
Let's do.
it's your choice. So
Yeah.
you can either do -5, which is again, you lost $10 because that's what he bet, and then he got $5 back. So he's still down -$5. Okay. So, all right.
So he
And
has
on
the
this other
decision to
side,
do the same, right?
Yep.
Yes.
Yeah.
So I'm assuming we'd have to do expected reward functions for each.
So there's
Okay.
another part. The payment when correctly.
okay. So let's start. Okay. Let's take a pause here. Okay. So drawing this tree correctly, you already got what fraction of the points?
0.4%.
Yeah, 40% of the
40,
points.
yeah.
So most people got this whole tree wrong. Okay.
This is tricky, honestly. I don't
Yeah, it is. The leaf part is a little bit tricky. So a lot of people got that wrong. The problem is if you get this tree wrong, you're almost
Everything
done.
Yeah,
Like you're not getting anything else. And that's makes it very similar to the first problem, right? Where if you get the tree wrong, good luck getting the rest of at least the second and third, or third and
Right.
fourth parts right. Okay. Okay. All right. So if Sean initially bets, should he cancel if they're winning at halftime?
Shouldn't you just put the reward at the end?
Oh yeah. So we need to put the
Money.
reward.
Yes.
So
Yeah. So let's actually
Probability
do that.
shouldn't go at the end.
So
no?
you lost a point for not putting the reward so far. Okay. Alright, so,
Alright, so then each of these are going to have their own.
yeah, so
charges.
let's
If
go
he
through it.
wins, then he has a
Um,
net of 20. Let me go ahead and put that 0.4.
Mhm.
Then he has a net of $20.
Yes.
And then this one, if he loses, then he has a
Negative 10.
Negative 10, I think.
Yeah.
Yes. Just write the probability.
Oops, 6. Is that
Yeah.
opposite?
Yes,
Would
yes.
you do-
No,
Yeah,
it's correct.
yeah,
6,
six,
yeah.
six.
Yeah. And then this one, same situation, $20. And then down here, negative 10.
Alright, so now you got full credit.
Mm-hmm.
Alright. So the first question is, should he cancel his bet if they're winning at halftime? Okay, so where's winning at halftime?
Right here.
On the
Winning-
right.
Okay, so we're at that, on the right, at that decision point. Okay? So the question is what's his expected reward if he leaves the game?
-5.
-5.
Yeah.
Okay. What's his expected reward if he continues the game?
You can
Then
calculate
you
it.
have to calculate it by the
Point
probability times the
Yes, plus.
benefit.
Okay,
all
let's do it
times
real
the
quick.
probability, right?
Yeah. Just
Oh,
do
no,
it.
no, no. So, because
No.
it's given, we already know.
Okay.
0.4 times 20 plus 0.6 times negative 10.
Or leading. It's going to equal.
Let's actually write. Okay, so here, this is a good point. Let's
Should I
write
move
that.
somewhere else?
So the statement you wrote is not correct. Sorry, not to be. I'm not trying
No,
to be
you're
mean,
good.
but okay. So let's erase the leading.
Because it's
Reward
given
will
that
be-
he's
So
expected
what's the
reward
decision? It's to continue or not.
stop, yes.
Yeah.
Okay. So you're calculating the expected reward of continuing.
given that
Okay.
he's
So
leading.
instead of leading, it's R subscript continue.
And then you put X for the random variable.
X is some random variable, and then the given actually goes inside.
The parent, yeah.
Yeah.
Given, leading.
Yeah. There we go.
Are you gonna be like
Yes.
okay.
If you're asking picky about notation,
Yeah.
depends on how bad it is.
Okay. Fair.
So the problem is sometimes if the notation's so bad, it's actually wrong. Like, a lot of times, it's kind of tough to explain, but
Mhm.
like, I'll say, what's the probability of winning the game given that they're leading at halftime? And people will write the probability of winning is 0.4.
Yeah. That's
And I go, no, that's not the question I asked you.
Yeah. Okay. That makes
Right? So,
Alright, so then 0.6 times negative 10, 20 times 24.
so 2.
Can we jump right into that, or do we need to write like?
You need to write
sum
that.
of-
Expectation. Oh, okay. Yeah, so if you write that top equation, I don't remember what I did if I took off points. I don't have it, so I'm going to say as long as you write -10 times 0.6 plus 0.4 times 20, you're good.
Okay.
But if you just write expected reward $2, you're going to get points off.
Right.
Mm.
Okay.
Okay, because I need to know where you're getting, like somehow I need to know where you got the number 2.
Okay.
Okay?
So right.
So alternatively, if you were to write, instead of those numbers, like this is equal to the sum of like some probability given leading times the reward of winning, then I get that as well. Because
Okay.
I
So
I
as
just
long-
need a work step somewhere
Okay.
between a statement and a number.
So as long as you can look it up, like you look at our paper, and go, okay, he knows exactly what's going on.
Yes,
Okay.
that's right.
Okay.
Okay, so we got $2. So let's look at the question B. Should he cancel his bet if they're leading at halftime?
Yes. So
No.
we need to
No,
figure
no,
out.
he
went.
went two.
Right?
No, so it's the given is they're leading at halftime. Okay,
Yeah.
so we're in that box.
Yes, he went
Yeah. No,
So what should he do?
continue.
Either lose $5 or
Or
win
win
two.
He should do
Yes,
it.
yes.
Yeah, because the expected reward is
Yeah.
higher.
So he should what?
Continue. He should continue.
Continue.
Yes.
So if they're winning, continue? Is that what it was?
Yeah. They're
Yeah,
winning
yeah.
the half continue.
Okay, so now the next question is if they're losing at half,
Yeah.
should he continue or not?
We have to calculate the
I
same
kinda
reward.
know this.
It's the same word, the same setup here.
Okay, so let's write it real fast
Wouldn't
then.
that be 0? Good. Expected
5.
reward.
No, it won't.
Continue.
How
X.
X.
Fine.
Given
losing.
losing.
Yeah. So, and then it's just the same thing you do.
Yes.
Equals -10 times 0.5 plus. Oh no, it's not.
You
Just
leave
0.
on.
20 times 0.5. That's 10. 5.
Five.
So it's 5.
Hey, pretty easy exam, huh?
Very.
That's not bad. I mean, we
Yeah, it's
we
not.
did that
No.
about.
Well, that's because
Back
I'm
to
helping
there.
you.
Yeah.
Trust me when
Yeah.
you're doing this in the.
That's true.
Yeah, yeah.
That's true.
So,
Yeah.
okay, so let's look at the. So what do? Do you cancel or continue?
You continue.
You continue. All right. So now let's look at this part D. Is there a consistent strategy?
Yeah, you always bet.
You always bet. So you always keep your bet on the football team.
Professor, let's say we had a
Yeah,
negative.
full credit.
We got a negative in part B. And
Oh,
part,
okay. So let's pretend.
we
um,
expected is a negative value. So what do we say
So
for
for
the
this
strategy?
bottom one, yeah, let's
Yeah.
do that. So let's pretend instead of winning $20, you only win $10
Mhm.
on the right. So like, it's going to be a weird bet, okay? Where if they're leading at half, you only get $10.
The same amount you paid.
Yeah,
Mhm.
which is dumb, but let's
Yeah.
just pretend, okay?
Yeah, just for
All right, so now let's update our expected reward equation. So instead of 10 there,
Or instead of 20, it'd be 10.
all right, yep. And
Mhm.
then when you do that multiplication, it's 4 plus
-2.
minus 6, so you get minus $2. Okay, so what do?
Continue.
Yeah.
You should.
You still continue,
Continue.
Why?
right?
You
Because
win. Wait.
you lose 5 or lose 5 or lose 2.
Oh.
Yeah.
It's better off.
Yes.
Mm.
Yeah. So no, you're gonna lose money. You might as well lose less
Yes.
Yeah.
money. And in fact, I think this came up on a problem at some point where, yeah. Okay, sorry. So let me. How did this happen? I don't know. I've had a problem where it worked out like this, where the expected rewards are like bad and worse, and you have to pick one.
Yeah.
Okay, and you just pick the least bad one.
Wait, but I have a question. Cause
Yeah.
like, if you know you're gonna lose, you're not gonna lose $2. You're gonna lose $10, right?
No,
this
you
is
don't know.
overtime.
No.
Yeah. So
Over time.
yeah,
Many
the
Expected
average
reward.
expected reward. Yeah.
Yes.
Gotcha.
Yeah.
And if it were like the same, then you would just write whichever.
Yeah. Either one.
Either one.
Yeah. Yeah.
So, Professor, for the last
You get
question,
that
is there a
average, right?
consistent
Yeah,
strategy?
it's over
Yeah.
and over and
It's
over.
It's just I don't that's what I don't understand here.
Yeah.
What-
Using the random.
Okay, so let's
It's a random Mario.
can you
You
put it
can
back
know when
to
you start,
20?
you know?
Yeah, so erase all the red stuff and put it back to 20. So the question about the game was is your strategy refers to the decision that you're making. Okay, you only have one opportunity to make a decision, which is at halftime. So does your strategy depend on whether they're winning or losing?
Mm-hmm.
That's what we mean by consistent.
Okay. Yeah,
Okay.
makes sense. Yeah.
So the strategy is, I always go with UCF, right? No matter what the score is.
Mm-hmm.
Okay. So a lot of times we can think of these as like, those decisions are like tactical decisions, right? In the instance, what do you do, right? But if you look at all the all those tactical decisions, they're all the same.
Mhm.
So it defines an overall strategy of always betting on my team. Okay.
Because he also from the beginning he never bets against them also.
Yeah.
Never bets against them.
Yeah, that
Yes.
was another issue.
Yeah, I get from this. He never so be consistent with his team.
Okay, so at this point, we've solved this problem in 15 minutes, which is awesome.
No,
If
but
you-
how many minds you thinking? Not only one thing. And
Yeah.
you're gonna avoid.
Yeah.
Yeah, if only one, you
But-
take more time.
Here's the important part. You see how it's possible to solve it within 15 minutes. In fact, if we got rid of some of the chatter, this would have been done in
Yes.
10 minutes,
Yeah.
5 minutes even. Okay, so
How many questions was this test, anyways?
4
Four.
questions. And
Okay.
nobody finished.
Wow.
Okay, so all the problems were about this.
Professor, is there a question here for The matrix thing where we have to find the weights and then find the score.
Yeah, so that was the first problem.
First
one. Oh, you guys
Unfortunately,
already
we
did it?
didn't record it.
Yeah.
But
So for this one, if we build up like something wrong in the tree, would we have like error for?
yes, the whole thing would be wrong.
We won't get any partial.
Probably
error?
not.
Oh damn.
So the typical way that these exams are structured is, there will be, I don't know, maybe there'll be 4, maybe there'll be 3 problems. One of the problems is going to be crazy hard that in the moment I don't expect people to get, which I believe was this problem. Okay?
Was this one?
Yeah. Yeah. I know it doesn't seem hard because we sort of stepped through it,
Yes.
but
How many points was the whole test out of?
100.
no, I think like
50,
31. Yeah. Okay, so you're gonna have one problem that's super hard and nobody's gonna get. Oh, this problem should be straightforward.
Yes. Yeah.
Okay, so actually let's do problem 3.
Yeah.
So hold on, should I pause this?
Make a new one.